So let me start by making a couple of comments about what Nancy was saying. So one is that just reacting to some of the statistics there, one thing that I would say probably is supportive of the wide degree of support for serverless approaches is that it's very common for organizations to use a serverless approach for just one little thing, but they're using that in production. And maybe it's 10 lines of code just to do like one little thing. Oh, if this server dies or if this thing happens, just like shoot an alert or something. So I think that one of the things that those stats don't really capture is like the sheer vast quantity of like code or importance or complexity that can be in, say, a containerized system versus a serverless system. And I can tell you that we actually use, for example, on some of the Amazon work we do, we use Lambda for some of those very little small things, and it's a super useful tool. So one of the, I'm not going to talk about serverless much. I'm going to talk more about microservices. There really isn't that much difference between the two in some regards. Pretty much everything I'm going to say is relevant probably to both worlds. They both require some shifts in thinking. I think anyone that is talking about one of those systems being an approach versus the other is probably got like a religious thing going on. What's really going to happen is you're going to end up with these systems are going to have some stuff that operates as on a serverless basis and some stuff more on a API driven basis, maybe what you would think of as being more conventional today. So these systems are all going to mix and match. In fact, one of the great reasons to go down a microservices path is the kind of use the right tool for the right job in a much more granular way. I should say that perhaps I'll give you some perspective on your comments about, wow, it's weird, like big companies are leading this. I work for Samsung, and we're a public company. I actually work for Samsung SDS. Public company. I'll say this probably needs some refactoring. This is clearly a big company monolith at work here. Darn, I thought that would get a better laugh. Too close to home for some, maybe. So, Cloud Native Computing Team is based here in Seattle. Why do we call ourselves Cloud Native? What does that really mean? We are, and I'll show you a slide in a minute, we are sponsors of Cloud Native Computing Foundation. I'm on the governing board. Thought it would be worth pointing out that this is what the Cloud Native Computing Foundation considers to be kind of at the heart of Cloud Native. Container packaged. I'm going to talk some about containers. I'm going to talk a little bit more about Kubernetes, which is a container system, container-based system. Dynamic management, this is maybe more advanced stuff for some systems. And of course, microservice-oriented, so we'll talk about that a bit more here as well. Because I work for Samsung, a very large company with a legacy of IT systems, we're of that class of companies that's trying to figure out how to go faster and be better and gain velocity. A lot of the techniques here are very useful for companies that are playing some catch up when it comes to the likes of a Google or an Amazon in terms of how we execute. So I'll throw this up here. I'll come back to Kubernetes a bit more, but this is really kind of part of how we operate as a team, what we believe in. Linux is the most successful software project ever, open source. My team we do 100% open source work. Kubernetes was donated to the CNCF. So if you want to think about the Kubernetes project, lives inside CNCF, which lives inside the Linux Foundation. Kubernetes is an operating system for a lot of machines running Linux, is one way to think of it. So you can think of it as the next-gen distributed operating system. And the lower left there is our logo here among the platinum sponsors of the CNCF. I'm going to spend a little bit more time on this because I think if you don't understand where I'm coming from and what it is we do, you won't appreciate what it is I have to say about it. Just by way of background, either myself personally, a bunch of folks on our team, you mentioned HP Cloud. We have built systems based on OpenStack. Was a very early user of Amazon, one of the first users on the Amazon public cloud. Have deployed OpenStack to production, have deployed Cloud Foundry to production, and now have deployed Kubernetes to production. So I think we have some track record that gives us some good perspective on these things. And we really think of all of these hard topics in terms of the technology side and the people side. For a lot of what we're talking about here, the people side is really more important What we do is help projects inside Samsung, but we also help companies outside Samsung. We're a business unit, effectively a consulting services business unit inside Samsung Group. All right. Why should you care? Should you care because everybody else is doing it? For some, not a bad reason. This is one of Adrian's slides, highly recommended. I think these slides will get posted somewhere, so if you want to come back and look at some of these references later on, highly recommend you going through and looking at this slide deck. The progression of cloud adoption in terms of classic IT's reaction to it is so spot on. And what's been happening is that kind of resistance has been collapsing. And so what we're seeing is new trends to really improve things are going faster, and you're seeing that in the curves. The Docker adoption has been, the most phenomenal, amazing, speedy adoption of a new technology, certainly in my career. But more likely, what you're suffering is deep organizational pain. This describes IT orgs for perhaps, 80 or 90% of the industry. People have built a lot of weapons for the last war. Dev teams are under pressure. Operations teams are viewed as just blocking things. It's very miserable. A lot of the philosophical approaches towards DevOps have been, I think, a very well-motivated attempt to try to fix some of the organizational dynamic here. I would also refer you to Joe Beta's talk this morning, which was excellent. That's like the third time I've heard it, and I like it every time, about the operations dividend in terms of trying to fix these kinds of issues. Also, so you have a lot of pain, but really the CEO, the CTO, the CIO have also started to really feel like they're not going as fast as everybody else. And indeed, these huge differences in ability for companies to execute have emerged across all three of these, right? So we're not talking about, pick any two. That's not the way it's been working. The way it's been working is companies that have changed the way they execute are doing way better on all three of these. And generally, the approaches that have been used, it's being called cloud native now. Some of these approaches, some of these companies, Netflix would be another good example. These approaches have been used. They weren't called cloud native, but effectively, that's what we're calling them now. And I actually don't like the name cloud native because it has this assumption that you have to build things natively as opposed to being able to take these techniques and adapt them to existing systems. Most of my talk is about how do you adapt this to existing systems without completely starting over. And but nevertheless, that's the term that it's picked up. So if you're down this path of trying to figure out, well, you feel like you're not as good as your competition, or as good as your competition might be getting. How do you evaluate your own organization's capability in this space? And this is there's the old school big IT bar at the bottom, and then there's the companies that have really figured out how to execute well. Amazon, Google, Netflix, Facebook. There's many examples out there. Those are the ones that people are commonly familiar with. There are many axes of excellence that you have to approach here. And what I'm going to talk a little bit about is the danger of picking, let's say, just the microservices axis and saying, oh, well, if we do just that one thing, we're going to be a lot better. Joe Beta wrote a really great piece recently, again, the references here, on orchestration versus jazz. And some of this is about Kubernetes itself. His article is a terrific article. If you're interested in how Kubernetes works, I strongly recommend it. It is really about kind of also transformation in modern systems design, which is not about prescriptive do X, do Y, do Z. It's really about how do you build a distributed system where all the components interact with each other, and about how do you use modern approaches from robotics and AI to create systems that converge on a common goal. My point, and if you go and look at some of these other charts later on, perhaps you'll see that I've said orchestration is one step, but the next step is jazz. I'm referring to I'm referring to Joe's article here. I think the really hard thing for companies to deal with is that this is not really a technology issue. This is an organizational issue. And if you're going to take advantage of a microservices approach, your teams are also going to have to transform from a centrally managed, hierarchically designed organization in order to be super effective. One of the things that's common across all these organizations is they've learned to embrace change. So I modified this last night because I realized this was not really saying what I meant, which is that high performance embrace rapid change with automation. It's fine to say, oh, change is great, change is great. The difference is, do you automate the process of creating change? Puppet Labs, I don't know how many of you are familiar with the Puppet Labs. You should read this every year. This is such a great paper. It will give you that handle on the difference between, like, where is the bar? I think the stats here are just stunning in terms of the difference between high performance orgs and low performance orgs. 200x more frequent deployments. Go read the paper. There's some other things there in terms of mean time to repair. Mean time to repair is much more important than preventing failures. And you'll see some amazing graphs in terms of high performance orgs versus low performance orgs. Getting to these numbers, a microservices-based approach, it will help you get to these numbers, but it's not actually required. So, change-resistant habits, change embracing. Change embracing really means, for both the org and the technology, embracing this notion of lots of small independent parts that can all change, and then being able to update them continuously with automation. So classically, if you talk to people about microservices, probably what they think about is these top two. The lots of small independent parts, however it is you're doing that. Hopefully, probably running each in containers. There's less attention given to the org impacts, which is small independent teams. How many people know what Conway's Law is? You familiar with that? Oh, that's so good. This is that system architecture follows organizational pattern. It's going to be very, very hard to have a microservices-based system with a centrally managed hierarchical waterfall-based team. You're probably not going to get there. So you have to, in order to achieve a microservices-based approach, you have to refactor the way the teams work. And then what I really want to talk about is fundamentals. What do you have to have in order to be successful at all? So, should you get busy refactoring your monoliths today? I'm going to tell you no. Well, only if your fundamentals are ready. Most companies that we meet with that are at this stage are interested in the benefit of microservices, but haven't fixed the fundamentals. And the fundamentals are critical. So how do we evaluate what those fundamentals are? I've been involved in extreme programming, agile programming, whatever it was called there for a pretty long time now. I've been involved in failures of agile programs more than once. I think what I've learned, what we're discovering is a successful approach with our customers is that you have to start with operations. So you can't have an agile dev team and not have agile operations, and you have to build from the ground up. High velocity is just not possible unless you have the entire org on board. You can't just do this with a dev team. I, again, strongly recommend this article. I've got a post here. I've got the URL there just about how, it says it better than I do in terms of how agile programs go wrong and how cloud native and agile are not the same thing. Okay, so where on this bar of things that you should be worrying about to achieve microservices nirvana do you really need to worry about? Not all of them. In fact, Google and Amazon, actually Samsung to a degree, worry about things like energy recovery and efficient data centers. Really only if you're running a lot of servers do you start to care about things like that. There are probably even things around like engagement with open source where there's a spectrum of maturity in how you engage. That's very important to us. We're contributors, active contributors on the Kubernetes project, for example. But that's not really, you could take a microservices approach with fully proprietary software. The axes to really worry about here are the the team, continuous deployment, and whether or not you have the technical underpinnings of a system that can do container orchestration or container jazz, as we're starting to call it. All right, here's my rant of the month. Maybe it's my rant of the year. Every time someone says CI/CD, a DevOps cat dies. Amusing, not so amusing anecdote. Within the past, couple of weeks, I had a conversation with a customer, and I was asking them, so just walk me through your CI and your CD, and they said, well, CI we use Jenkins, et cetera, very normal conversation. For CD, we do that manually. We have a team that does CD. Okay, that's not CD. Perhaps we should be calling it AD, automated deployment, but CD means you can go to production with automation, quickly and with risk. People doing CD, that doesn't count. And just to kind of make that point a little bit more, there's these various kind of roles and important things within the company. Now, I'm not saying these are groups, but these are important tasks. And it's important to think about, like, from development to operations is CD. How is it that you manage quality assurance around a development process? That's CI. And monitoring, which is something that's very close to us as well, is something that happens as really like the gap between QA and monitoring in this world is also shrinking pretty much to zero, right? QA is something that does not happen continuously in development as part of CI. It needs to happen continuously in production. And now you're starting to pull all these things together. All right, so far, lots of talk. I think what is more useful in these kinds of conversations is, well, all right, that's a nice theory. Can you actually execute on this? So this is one of our customers. This is their situation, pretty much exactly what I was saying before in terms of kind of classic state of IT that occurs at most companies. I think that their pain is also very, very typical. Changes always cause problems, a weekly deployment done by hand, all hands on deck, lots of fear and angst about every deployment, lots and lots of energy going into that on all sides, which detracts from the ability to contribute to other efforts. I think also really critically, development teams unable to get access to test environments, to do experiments, to do quick development. This is a really critical thing. We see this over and over and over again. I'm going to put some stuff up that at least some of you in here will raise an eyebrow at, I guarantee you, but it's really critical to solving this problem. Classic three-tier stack. Okay, so typical consulting org would come in and say, oh, well, we'll put a team in beside and try to fix this. Oh, you've got the wrong people managing the team. Oh, or let's just work on a complete system rewrite. What we've learned is an approach is modernize operations first. Again, this is the sort of ground up, get the fundamentals right, get to a point where you can start making incremental changes. Then you can start building microservices on that basis. So when you get the fundamentals right and you need to start refactoring the applications, you can do that. You can start breaking them out into microservices a little piece at a time. So again, summary of our approach, actual customer, containerize the existing applications. This is very critical. Containerize within the existing deployment tooling, assuming that you have something like this. A lot of companies have Chef or Ansible or build RPMs, or there's some way they're managing that in their existing system. If they're not even that far ahead, you probably have a little bit more work to do in something like this. So our approach here was to take those containers, deploy them to Kubernetes, use some of the tooling in the Kubernetes community, specifically Helm, to automate that, wrap that deployment. Work indeed on the CI system, that's important, to ensure that as the development artifacts are created, they can be deployed with confidence, and then begin incremental development updates. So the starting point, again, just nothing special here, right? This is very typical IT kinds of systems. Application stack here. One of the interesting, unique things about this situation is we're working in a fully hybrid environment using Google Cloud in this case and on premises. All right, here's the thing that I know I'll get at least one eyebrow raised, but we think this is really important, which is how important it is to use containers to containerize everything, to have deployment tooling that covers everything, including databases. We consider this to be best practice. There is a ton of tooling and approaches that have been built into Kubernetes to support applications like this. If you can't get the database part of your system also containerized, automatically deployable, then you'll never get the development team freed up in order to make rapid progress. You'll have a hard time spinning up systems in order to do CI and other kinds of QA activities. This is really that kind of the key starting point here, which is to automate that delivery pipeline. Containerize, take some existing assets, containerize them. By the way, once you containerize something, this is really critical, you now have a completely repeatable deployment artifact. So you can deploy that now. Well, I'll say you can deploy it with confidence. You know that the behavior of that is going to be consistent. Now, maybe it's going to be broken, but at least it's broken consistently or it works consistently. And then have a regular way to push these containers through from the deployment system into production. This brings key velocity improvements of, again, the dev test environments, deployment automation, removing the angst and thrash. If you're interested in this as a case study, we did a much longer talk on this at the last Google GCP conference. I've got the link in here for those who are interested in going and looking at it with all sorts of detail here. So takeaways, summary of this, our learnings here. So first, containerization is extremely important, which means that if you're starting on this journey, you need to choose a system that will support containers. You can package legacy systems into it now, but as you make that move towards microservices, you don't want to have two different systems. You want to have your monoliths containerized, deployed on Kubernetes, and then as you split those microservices out one by one, they get to be deployed into the same environment. You have to build operations and testing automation, cover those fundamentals. You get significant advantages out of building these fundamentals before you even start down the microservices path. So this is not work for no benefit. This is work for a lot of benefit, putting you in a position where you can then achieve the greatest benefit. And then I would strongly say you have to factor out the microservices slowly and incrementally. This is not just technology, this is the team. The teams have to understand, how are we going to do this? Can we independently deploy these things? Have we figured out an API versioning strategy so that we can have multiple versions of the software sitting out there? Can we do roll forwards and roll backs, or roll forwards and more roll forwards? Can we repair broken deployments quickly and automatically? Learning Jazz is hard. This is takes transition for the team to do this as well. Okay, red flags. If you can't actually automatically do the whole thing, you're probably going to be stuck. You should not be looking at a microservices-based deployment if you can't do that. If you can't deploy microservices independently, I have met with CTOs who told me that they thought microservices were a bad idea because they had made their system so much more complicated, and when they did their weekly deployment, they had to deploy everything. The system was so much more complicated. So there is a case where someone was like after the benefit, but didn't really understand the strategy. Let's try to keep from making those mistakes. You know, if you don't have an API versioning approach, these are the kinds of things you have to work out for your organization. How is it that you're actually going to independently upgrade and monitor these things? All right, so that's really the end of my main comments. I have talked about Kubernetes a bit. I want to talk about it a little bit more. Kubernetes is a very important project to us. We were very early contributors and supporters of the project, pre 1.0, in the axis of, I'll say, mature consumption of open source. We are dedicated to running from trunk, no forking. We push all of our work back into Kubernetes. Some of the work we do is sort of on the, I'll say, on the outskirts of Kubernetes. It's there, fully open source. We expend a lot of effort helping with sort of community organization activities, especially around scalability and testing. I already mentioned our involvement in CNCF. One of the main projects you'll see on our GitHub page is an open source project that's around using Terraform and Ansible to do kind of large-scale Kubernetes cluster building. And I think I'm done. How much time do I have?
You have okay? About 5.
About 5, okay. So questions? Oh, there must be one. Yes, thank you.
If you're building small independent teams, how do you get them work together? Don't they have to, at some point, build something
I would say yes and no. If you look at a company like Uber, and I have seen more comprehensive stats on microservices from somewhere in Uber, but again, it's a kind of distributed company. Their microservice to developer ratio is greater than 1 to 1. So they have more microservices than they have engineers. One of the things that happens in an environment like that is people put services out there, and if no one finds them useful, then they die. So part of what you start to see in a little bit larger organization is some like economies that are very similar to the way open source kind of economies work, which is code speaks, you put a service out there, if people find it and use it, then more energy gets put into that. So some of that is organic. I'll say that companies that have how to put this gently, don't have really great product management teams are going to struggle with this, because the priority on establishing the product vision and making sure that everyone understands where the team needs to go, establishing the vision and direction are A, it's really important, and B, it's harder to find product management folks who will live in a, I'll say, vision making and kind of statistical reporting, like here's where we should be and here's where here's where we are and here's where we need to be, as opposed to wanting to run a command and control org, which is actually like emotionally easier to say, oh well, we should be doing this, like when's the feature going to be done. There is, if you read that, if you go back and look at the article about the cloud native apocalypse that I referenced earlier, he references some work around using key objectives as one of the techniques for how is it that you make sure that everyone has the incentives to all be going in the right direction. It's a hard problem. I think that anyone who has worked on a large successful open source project like Kubernetes, that actually becomes its own education in terms of, well, wow, we have, I don't know, 2,000 or 3,000 developers working on a system without any central management, and yet we're actually able to make substantive progress, even though there's all kinds of different in some ways disconnected teams working on things. Yes?
Should the microservices be always treated with an enterprise service in mind?
Oh, certainly not. No, I mean, if you're oh, I'm sorry, the question was, should microservices be built as from an enterprise perspective, which I think what you mean is granular authentication, other kinds of controls, perhaps.
Also from the capability perspective, the performance need of that service. So.
I guess I'm not sure how that's different for any company that's interested in building software. I mean, you're going to find that at a larger, more complex organization that things like service catalogs get a lot more important. If you have a relatively small org, then like here's our list of microservices, post it on Slack, right? That's not what a lot of people would say. Oh, that's not an enterprise approach, but that's just a question of scale. Yes. Well, how sick is the patient? I think most companies that are at this stage, if you're not prepared to spend a hard 6 months to a year working on getting these things sorted out, then your expectations are probably a little out of whack. I mean, this is not easy stuff. This is the reason our team exists is because this is such a hard problem, and a team that doesn't know how to do this is going to have a very hard time bootstrapping themselves into, oh, well, we have to keep the car running, and we have to put a lot of effort into this kind of really critical but yet high-risk thing that they've never done before. That's the role that's what we do to help out Samsung groups inside that need this kind of help inside Samsung, and also the help that we give to groups outside. Yes?
You guys use a service mesh, and you see it as a recommended element of a holistic solution.
We are not yet recommending a service mesh, but this is something we're following very carefully and closely, and we'll be probably kicking off a production project with one of our customers using a service mesh. Istio or Linkerd are probably the two that, those are not quite those are not exactly comparable, but those are two that are, Linkerd is a CNCF project. So that's one that we have a lot of affinity to, but Istio is, appears to be on the right track in many, many ways. And the fact that it's so closely aligned with Kubernetes makes it of deep interest to us. But we're just not there yet in terms of a formal recommendation.
Okay. Should I read that as an opinion about Envoy, or is it just how?
Well, actually, Envoy is being used inside some of the new Kubernetes work, so it's not a commentary on Envoy. Istio has a lot of embedding of another project called Spiffy in it, which is really about kind of microservice to microservice kind of authentication and management, and a different approach or a more comprehensive approach to microservice to microservice authentication and security. I hesitate pretty much always to say, well, we're going to pick or recommend an integrated stack of everything from top to bottom, which is what, for example, if you go down like the Cloud Foundry path, you're going to find the whole system is very prescriptive from top to bottom in terms of like how all these pieces fit together. The Kubernetes and the Kubernetes ecosystem is not. So it's very easy to imagine, well, we will use Istio for this customer because it fits their needs better, and we'll work with Linkerd on this other customer. We've actually put work into load balancer approaches, for example, that are specific to a customer engagement that are neither one of those. Yes? I have a whole presentation on that, but I think I'm out of time. Yes, and here, let me just give you a quick glimpse of it here, which is, I stuck this in I was like, someone's going to ask me that question, so I stuck the slide in my backup deck. Yeah, there's a lot of thought that needs to go into getting the organization right here and how you separate these concerns. I'll say I echo Joe Beta's sentiments from this morning. One reason I love that talk so much is that this notion of DevOps as generalists that get stuck with doing everything. Let's hire the heroes is kind of what that turns into, is not a scalable approach. Right? If you're 5 people in a garage, that works great. Right? I've done that kind of project. That's true DevOps. All right, everybody's responsible for everything. You're not much beyond 4 people working before you start having to worry about specialties. You have to be very thoughtful about that. So maybe come talk to me afterwards. We could talk about it a little further. Was there a question here?
I'm not sure about test automation. You mentioned it in your conversation. Where does PV fit into?
Well, I think what I was trying to do, and by the way, keep me honest on time here.
This might be the last.
Okay, last question. I certainly don't want to. CI and test automation is super, super important. My point was, if you can't then actually deploy to production automatically, you haven't done enough. And this is back to agile dev. Often, agile systems often, or agile operating dev groups will often, you almost always have some kind of CI notion built into them, but then they can't get to production fast. And so they do lots and lots of loops, and then they get super frustrated because they can't get their product shipped. If you're not, the agile religious view, which I would endorse, would be if you're not getting to production, you're not really agile. And I think that seems like agile dev is almost a contradiction in terms that way. We spend a lot of time on CI. We spend a lot of time on CI for Kubernetes itself, for the K2 project, with our customers. We're primarily a Jenkins shop, but that's just like a piece of the framework. I'm not sure I'm answering your question, but all right. Yeah, that was a sanity check on the CI matter. Yes. Okay. Was that it? All right, great. Thank you so much.